Right, so when we come to graph reciprocal functions, they are no different to graphing anything else, okay? You have to first off find, what do you think first? Oh, have I not? Apologies. Alright, there we go. Alright, so graphing any kind of function, what do you always kind of have to work out first? Yep, so the first thing you have to do is find the X and Y-intercepts. Okay, and in the case for reciprocal functions, what are we going to have to work out? Because what's the extra thing? The asymptotes. Okay, we have to find out what the asymptotes are, which are just an extra part, okay? Now, we all know that the shape of these asymptotes, if I do it's a sketchy sketch. Asymptotes are always going to look somewhere like, that, and, could look like that. They're always that type of shape, okay? Yep. It might be up there, it could of course be reflected. Okay. But they're always that type of shape, okay? Same as quadratics. Quadratics are always the same type of shape. The smiley face or sad face. Cubics are always the same type of shape. Reciprocals are always the same type of shape, okay? So let's have a go at one of these. So, and we'll talk about how we work out the asymptotes as we work through it. So we're going to sketch. Y is equal to 1 over x minus 2. And what I'll do is I'll draw my axes down here and we'll kind of sketch it as we work, as we figure stuff out. Right, so let's do the y-intercept first. How do we work out the y-intercept? Yeah, the y-intercept occurs when x is equal to 0. So when x is equal to 0, what's y equal to? Yeah, so 1 over negative 2, which is just negative a half. So when x is 0, y is negative a half. So I can put that point in. So my reciprocal function has to go through that point. Okay? Yeah? All right, what next? Yes, we'll see. So remember, these reciprocal functions are always the same type of shape, but they can be moved over or up or down, okay? So when you'll see whenever it's finished, okay? How it looks. Our x-intercept. So our x-intercept occurs when y equals 0. So if I put 0 is equal to this, what do we notice? How do I solve that? 0 equals 1 over x minus 2. What would be the first thing you would do? Okay, if I multiply, that's what I would do. I would multiply by x minus 2. Now when I do that, what do I get on the left-hand side? No, when I multiply by x minus 2. On the right-hand side I get 1 times x minus 2 over x minus 2, so the x minus 2's cancel. I just get 1. Now that looks a bit funky, yeah? A bit weird. So alarm bells are ringing here, okay? So there's no solution for this, okay? There's no value of x that I can put into here that's going to give me an answer of 0 out. Agreed? There's no value that I can put for x that's going to give me a value of 0 out. So something weird is happening here. What do you think is likely going to be happening? Right, so if it never reaches, that's not how you spell weird. Weird. That's still not how you spell weird. W-E-I-R-D. Alright, so if there's no value of x here, what do you think is happening at this point when y is 0? What do you think is happening at that point?
There's no x value.
Right, so it could most likely be possible asymptote, okay? Possible asymptote, so it will be an asymptote. Alright, so I can't fill anything in for this one, for our x-intercepts. It's not going to cross the x-axis, this graph, okay? It's definitely not going to cross the x-axis. Alright, so we're going to look at our asymptotes. We're going to do our vertical one first. This is the easier one. And we're going to think to ourselves, what value of x does function y not exist? What value of x, if I substitute a particular number in for x, what value is going to make this function not exist? What's going to mess it up?
2.
Why 2?
Because it's undefined.
Right, because 2 take away 2 is 0. Can we do 1 divided by 0? Nope. Okay, so the value of 2 is going to make this function not exist. Okay, so that is where our asymptote is going to occur. Now the easiest way that you can think about it is you take your bottom, what's on the bottom, and you put it equal to 0. You solve it. Okay, this is my asymptote at this point. My asymptote is at the line x equals 2. Now where is the line x equals 2? Yes, good, Darius, thank you. And Tamara. So there's point 2. And x equals 2 is going to be a straight line. I'm just going to put this in and then fix it after. And we said we represent our asymptotes by using a dotted line, so make it dotted. Alright, so that is my asymptote. And all this is telling us that the function does not exist at this point, okay? If I put 2 into this equation for x, I get 1 over 0, which makes no sense. So for the horizontal, we're going to divide each term by the highest power of x. So what is the highest power of x in this question? Highest power of x. Yeah, x to the 1, okay? So I'm going to divide every single term by just x to the 1, okay? Alright, so I'm going to divide each term by the highest power of x. What's 1 divided by x? 1 over x. What's x divided by x? 1. What's 2 divided by x? 2 over x, okay? So I've taken this and I'm now writing it as follows. Has it changed in any way? No, it's exactly the same equation. I've just divided every single term by x. Now, just as a little aside, if the equation was 1 y equals 1 over x squared minus 2, I would divide everything by x squared, okay? If I had x cubed on the top, x cubed over x squared minus 2, I would divide everything by. So I've got x cubed over x squared minus 2, I would divide everything by x cubed, because I divide each term by the highest power, okay? Whatever the highest power is, that's what I'm dividing by, okay? Yes? Okay, right. Now, our horizontal asymptotes are to do with what? If I draw up here, there's my x and y axis. Let's imagine there's a horizontal asymptote. They're to do with what the graph is doing when what? We talked about this.
That's where it never reaches the 1.
Yeah. So it's way out. What happens to the curve when x gets really, 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 really?
What's going to here?
No.
It gets closer to the number.
closer and closer to, like, my value of x. What's happening? My value of x is this continues way out. Yeah, it's going towards infinity. Okay, so remember we said that in order to write this, we said what happens to x, sorry, what happens to f of x as x goes to positive and negative infinity. Okay, we're trying to figure out what is this particular value. Okay, what happens to our function as x gets really, really, really large, or as it gets really, really, really small. Okay. Yeah. Now, this is probably a bit more important for the HL, okay, but you guys still need to be aware of it. So looking at this, we want to figure out, so if I just write this down again, we want to figure out what happens to our function as x gets really, really large, goes towards infinity, in a positive and negative direction. We want to figure out what this particular number is. So looking at our equation here, as x gets really, really, really large, what happens to this number? 1 over x. Excuse me. It gets really, really small. And by really, really small, it goes towards... No. 1 over a massive number is going to get closer and closer to 0. What's going to happen to 1? Is it affected? Yep, the 1's unaffected. What's going to happen this? That's going to get closer to 0, okay? So I've got a 0 on the top. So this is telling me as x goes towards infinity, y goes towards 0. And the nice thing is, it's going to be as x goes towards negative infinity, what happens to the top line? It's going to go to 0 as well, because 1 over a massive negative number still is going towards 0. It's telling me this is going towards 0. Now, this may not always be the case, which is why you have to check this, okay? So my second asymptote is on the line. My horizontal asymptote is anyone? Y equals 0. That's the line y equals 0. I'll do another example with these horizontal ones because they are a bit funky. Okay, so now I've got all the information I need. All right, so my graph goes through this point. Does it touch this line? Nope, it gets closer. So it's going to go, and I excuse my drawing here, but it's going to get closer. Do not let it touch or you'll lose marks. Has to go through that point, and it's going to curve down. Doesn't touch that point. And then on this side, it's also going to do the same thing. It's going to be close to that line, that asymptote. Curve down, make it nice and smooth. And it looks like that, okay? Jesse, you all right? Okay. Let's do one that is similar. Okay, let's do this one, okay? So exactly the same process, okay? I want you to work out first your y-intercept. So that's when x equals 0. Then I want you to do your x-intercept if possible. That's when y is equal to 0. Then do for me your vertical asymptote. And then we'll do the horizontal one together, okay? And sketch, or put in all the information that you have. You can do the first 3 bits, okay? Yes or no?
Yeah.
Okay. All right, so just to kind of quickly go through the first couple, okay? You've all worked out that your y-intercept is negative 1/6. So it's going to go through negative 1/6, negative 1/6. What about your x-intercept? So that's when y is 0. That sounds sensible. So you multiply both sides by 2x minus 6. So that gives you 0 on that side. You get 4x plus 1. Good. We all look at it with this next again. So you've got this equals 0. In order to solve this, how do you get rid of that in the bottom? You just don't multiply both sides by it. Yeah. So you end up with 0 equals 4x plus 1. So multiply by 2x minus 6, multiply by 0, I get 0.
Oh, I'm so dumb.
Oh!
Yeah, does that make sense?
You being 0, I would take it off.
4x plus 1.
Here's a 4.
Darius, you good with this?
Yeah.
So what does x equal? Yep. So x equals negative 1/4, so it's going to go through negative 1/4. Okay, so it has to go through these 2 points. Now you need to work out your asymptotes.
I don't know how to do the first one. I mean, horizontal. Yeah, okay. Yeah, that's correct. I don't understand this.
Okay.
So
Let's talk about this. Okay, but that's what you thought was good. Like some vertical asymptote. So how do you work out your vertical? Yep. Which part do we let equal 0 for the vertical? Which part of this? Yeah. How do we work out the vertical asymptote? Come on, it's what?
Figure out what X would
Yeah.
make that not. So X would be uh,
Remember, our vertical asymptote,
-3.
positive 3. Why?
Because if you times positive 3 by 2, that's 6. So 6 minus 6 is 0. And then
Right, okay, you have to think, okay, I can't have 0 on the bottom here, okay? So what value of x gives me a 0 on the bottom? So I'm just putting the bottom equal to 0 and solving it. So x equals 3, okay, and hopefully, and then you can check it. 2 times 3 is 6. 6 take away 6 is 0. That's going to mess this up, okay, which is what we want. So I'm going to have my asymptote in there. I don't want to do that. Let me use a different color. Okay, using a dotted line. Try and get into the habit of labeling them as well. So this is my vertical asymptote. And then let me know when you're ready to do the horizontal one. Okay, so in order to work out the horizontal, we divide by the highest power of x. What's the highest power of x? Yeah, x to the power of 1. Okay, so what's 4x divided by x? 4x divided by x?
4.
Is 4x over x, which is just 4, right. 1 divided by x is just 1 over x. 2x divided by x is? And 6 divided by x is 6 over x. Now, we said that in order to figure out what's happening at the... We want to see what is happening to our function when x gets really large, okay? So we're going to look at when x goes towards a massive, massive number, okay? Is the 4 affected? Is the 4 affected? No. 4 is not affected when x gets massive, okay? The 4 just stays the same. What is 1 divided by a massive, massive, massive number? A very small number. A number that's close to 0. Okay, so that's going to be going towards 0. What about on the bottom line? Is the 2 affected? No. The 2 is not affected because there's no x's beside it, okay? What about 6 over x? What happens to 6 over x as x gets massively large? It gets smaller and smaller and closer to 0. So what do I end up with? Ooh. As x gets really, really large, both these bits go towards 0, and I'm just left with 4 over 2, which is 2. And is it going to matter if, does it matter if it's positive or negative infinity, what's happening with this? No, it doesn't. So my other asymptote is at x equals 2. Sorry, y equals 2. Which is going to go like that. And then we can draw in our curve, so it has to definitely go through these 2 points. Do not let it touch the asymptotes. And it also comes down this side as well. Let's just label this asymptote. This is y equals 2. No. Okay, so we're almost up. Just in relation to these asymptotes, especially the horizontal ones, what we're looking at is what happens to the graph as x gets really, really large, okay? As x goes towards positive infinity or gets really, really large, our graph is going towards what value? It goes towards 2, okay? As x goes towards negative infinity, the graph is still going towards 2, okay? And that is what we have worked out there, okay? And this is just merely the method to do it, okay? Which is important for you guys especially, okay? Any questions on that? Okay, let me just stop. If you could do that one for me, start it now, see if you can get it finished for tomorrow, okay? Oops, sorry, did I just put the screen off? Hey, Mr. Potts. Okay, so I want that one done for tomorrow, okay?